You all know me, most of you know me. I've been around this event for quite some time. I've been talking on a various number of topics, both technical and less technical. Today I'm unfortunately going to be a little bit less technical than normally, but I still want to reiterate, I am an engineer, not a sales guy. That said, Xyratex has been around for a while, even though I've only been with the company for 1.5 years, as most of you know. But I wanted to at least give you a view of where we're going with things and a little bit where we've come from. So, Xyratex being an OEM partner to a lot of the big vendors out there, whether that be EMC, Dell, HP, and in the beginning, even DDN and BlueArc had hardware from our company to build their business upon. We decided when we went into the HPC market that we wanted to do something a little bit different. We wanted to do something that reflected the knowledge and know-how of building very dense, very reliable, very large systems and being able to produce these at volume and at really, really good cost. But still being an OEM company, which is kind of a challenge a little bit. So we came up with this solution that you see on the video up here with easy access to disk drives, so everything is hot swappable in the field, everything is enterprise reliable, it has the same building blocks as the commercial products being sold to other OEM customers not used for HPC, but we kind of side purpose it a little bit with applying software on top of it. The main issue of these very dense solution is, again, as file systems grow, and we heard earlier John talk about, actually didn't talk about the software side, but he made the storage side, but it was mentioned as one of the big challenges going forward. And we think that we may actually have part of that solution in these systems. And it comes down not just to the hardware itself, it also comes down to the software stack, to the end-to-end manageability of a large system from every software aspect in these systems going forward, which is why we think that our solution with an integrated software platform, everything from a single vendor, everything supported by a single vendor, is the way forward. But it also comes down to serviceability, which is why everything is accessible from the outside. Every active component is hot swappable and 100% redundant in the systems. And that goes for application controllers or embedded servers in the back, the fan packages with optional battery packs inside. It goes to the power supplies, which are industry quality, fully redundant power supplies, 2.8 kilowatts per power supply. Everything in a very dense factor that gives us this kind of solution. I hope you excuse these long, wordy things, but I had to fill out the video with something rather than just graphics. So today is about a year ago since we delivered our little baby, a 2,500-pound baby, but it's still our baby. It's been around for a while. We had ideas when we wanted to do these, fully factory integrated solutions. We wanted to have systems that are fully tested before it actually reaches the customer and not being shown up as dead on arrival or component not working, or where is that cable that's supposed to be in one of these million boxes that we deliver. Everything comes pre-cable, etc. We did that. We showed it off. We've been working with vendors ever since. Our first OEM partner, Cray, is out there selling their version of the system called Sonexion, and we've been around the block for quite a while. So even though we may not have shown up in too many data centers, we've been kind of working on some of them. But the important thing about this system is that it has been proven to have the performance we said. We said that we could do 3 gigabytes per second per enclosure. We can actually do, with the measurements we've done now and the optimizations, 3.5. That means that in a single rack, we can do 24.5 gigabytes per second performance. Now, I really want to iterate, this is file system performance measured by IOR. This is not aggregate theoretical disk bandwidth or some crap like that. This is actual performance you get into your compute systems. And it will scale linear. This is one of the reasons why we are currently building a small system that you may or may not have heard about. It's really hard to see from this slide, but if I have a laser pointer here, yes. So you see these 3 rows of racks over there. That's a scratch file system being built somewhere in the US at the moment. We actually installed the last rack, which is that one, got installed on Friday last week. So the system is now up and running, fully integrated, and will be connected to this small compute system that sits in the back, about 25 rows of systems back there. So we should be able to produce some real live numbers of this within a very near future. But this was only step 1. What is the next step? So with not too much ado, I want to introduce to you the ClusterStor 6000, the next generation of this system. The rack is fairly similar to the old one. Actually, it's exactly the same rack. It's exactly the same enclosures. What we've done is we've changed the embedded servers in the back. We've added new servers based on the Sandy Bridge technology. It's using FDR InfiniBand out the back of these, so we have really the bandwidth we need to do things. We add more memory. We can do 40 gigabit Ethernet, and somebody actually wants to do that, but FDR is what we will focus on. But it's still the same software stack. It's still the same disk subsystems. It's still the same management solution. And that means that we can actually upgrade a ClusterStor 3000 system to a ClusterStor 6000 system live in the field without replacing anything than a hardware component in the back and a little bit of changes to the software so that it actually recognizes new MAC addresses, stuff like that. That's it. And that's how we can increase the system from the current performances to future performances, and I'll get to that in a moment. But it also means we have a new architecture that will support future technologies like T10diff, which we will demonstrate very shortly in the system. And we're working for full end-to-end integrity there. Those of you who were at the Luster user group meeting a couple of months ago in Austin saw a big presentation on what we're trying to do with T10diff and how we want to be able to do that from the application all the way down to the disk drive. Everything to create enterprise reliability in a HPC file system. And we are going to get there. So from a performance-wise, we've gotten to the next level. So a single SSU can do 6 gigabytes per second. And again, this is measured IOR bandwidth from clients, not theoretical numbers. And that means we can scale to 42 gigabytes per second, at least, in a single rack. File system performance. That's how we can deliver a system like the one I showed you on the picture earlier, with 30 racks that will do 1 terabyte per second aggregated bandwidth. Think about those numbers. That means that we can actually do an exabyte per second in 3,000 racks. Okay, yeah. We might not be quite there yet, but you get the picture, right? At least density is getting to a point where it's theoretically possible, but obviously. So all of these things aside, I actually don't want to spend any more time on the hardware because hardware is kind of trivial. We can have a discussion in the booth if you want that, and if you want even more details, we can always sign you up for an NDA presentation. But I also want to talk a little bit about the enhancements we did to the ClusterStor Manager. Those of you who have seen my presentations earlier know that I focus more on the management of these systems than on the actual hardware and technology, mainly because I think that's important. So some of the things we've done with this tool that will not only install the system from bare bone metal all the way up to a running file system, it will also manage it during the entire life of this system, which includes firmware upgrades, hardware upgrades, disk driver upgrades, backplane upgrades, in addition to software upgrades in forms of OS, security packages, etc., etc. Everything would be managed by a single interface running on these systems. We have a new dashboard that didn't quite make it through in this resolution on the screen, the dump we did, but it will scale to this point. It will be able to pinpoint a single broken component in the system going forward. And it has 4 main fields where we'll be able to monitor the network topology, we'll be able to monitor the hardware component, the file system stability, uptimes, etc., with a single view on the screen. There is a drill down so we can see every single system nicely color-coded. Green obviously means that everything is working perfect. but it will immediately change color if a single component or a single logical step in this entire chain doesn't actually perform to spec. Everything is drilled down to even more levels so that we can actually go in and look at different components layers and different performance layers, either on a single system or system-wide. And this means that, for instance, if we look at this one, I can't actually see it here. I don't know if you can see this line, but it actually says true status. That means that every single hardware component that are running is monitored at any given time. If there's nothing wrong, the system won't actually change color. If a single component is, or if multiple components go down, it will immediately change color and not only tell us what's wrong, but also how to fix it. We have power supply status, the embedded servers, fans. We've got power statistics. I'll show you that later. We've got thermal statistics, voltage statistics throughout the system. This means I can start gathering information not necessarily just about the file system, but also about the hardware environments. I can actually plot the power usage of every component going forward and see how much power I'm actually using rather than just doing an estimate of these systems. In this case, and you can see we probably are using Cerebro as the underlying feature here, but we actually pick out, and this is power supply voltage over time. We can see that we have a fairly stable things where when we run benchmarks, we get a little bit of twit in these things. And this is on a per power supply basis throughout the entire system. We have ways of zooming in on events, and all of these things are obviously stored in a database, so we can always go back, look later, or extract data later for these things. In this case, it's, I can't even remember, this is ping times in the system, which will give an idea if the IB fabric is actually performing to spec, etc., depending on the load. We have other things such as a help system in there. Everything is computerized, obviously, so the help tab will not only show us, information about the system. It will also be a guidance so that if we have an error somewhere and we have a problem, I can click on that problem, go directly into the help tab. Help will not only show me which component is wrong. If it needs to be replaced, it will tell me exactly what the order number for that component is and how to actually get that done. If it's a software component that can be fixed manually, it will actually tell you how to fix it. If you need to rebuild a RAID set, or if you need to change the rebuild RAID of a RAID 6 set, it will tell you exactly how to do that using command line. So there is a lot more in these systems than just a management interface. This is a help to help yourself system as well, in case you can't get an engineer on site within 2 minutes, which is usually what the managers want you to fix a system in. But the other thing is that when we have issues here, for instance, in this case I did a screenshot where you can see an issue where a single component, actually there's more than one component, otherwise it would have said which component it is, so it's more than one component gone down. But you can see out here there is a little toolkit marker. If you click that toolkit marker, it will get you to the help page where we show you your power supply is misbehaving. This is an order number for a replacement unit, for instance. Or this is disk drive number XYZ that has been labeled bad. This is a new order number for a disk drive. It will also tell you which disk drive it is. It's drawer 3, disk number 24. When you go to drawer 3 and pull it out, that disk drive will light up so you see exactly which one to replace. Everything to make supportability of this system easier and better. And everything presented with a single pane of glass. Now, I know there are some nerds out there, some of you guys who think the command line is still king. Well, you can get all of this information in command line as well. We have a dedicated command line tool that will give you health statistics, uptimes, through replacement list, everything in command line. So if you have a big brother system somewhere, it can be tied into this fairly easy. There will even be an SDK delivered eventually for these things, so you can start writing, overriding scripts from a master system somewhere. But everything is decided in this system to be built so that we have supportability, manageability, and reliability going forward. Because one of the biggest problems we have is that when we start to deliver systems such as Blue Waters, for instance, we have a lot of moving components. Now, from a compute point of view, we've always had systems that tell me if the system does not necessarily perform perfectly, and if we lose a node or two, it doesn't really matter. If I lose a RAID set or two, it will matter because it will actually slow the entire system down. So building in enterprise reliability in an HPC scratch file system is not a bad idea. At least we don't think so, and some of our customers agree with us, and I think that's the step forward. So to summarize a little bit, we now have two systems on the market, the ClusterStor 3000 and the ClusterStor 6000, which is a little bit faster, actually it's a lot faster, a lot more capability when it comes to future technologies and future events. But it's still the same system. It's still the same basic software, hardware environment. And that also means that buying the low-end system because that's what we need for the next year or so, and then realizing in a year's time, oops, I need more performance, but I don't want to do a four-click upgrade. I can still upgrade at very reasonable cost to the next level and get more performance out of the same hardware. And we think that's a really good value add going forward. And the fact that everything is fully supportable for up to 5 years also means that the total TCO of these solutions are very well protected indeed. Now, as usual, Brian was cheap and only gave me 20 minutes, so I need to wrap this up. Otherwise, I could have done this for hours on end. But in this case, I'll actually just show it to you. If you're interested in having more discussions, we naturally have a booth downstairs that hopefully will be in working order by this time tomorrow. I need to get down there fairly soon to make sure that it is. But we have a big booth down there, including a very impressive demo of a file system running over a 11,000 kilometer link to be able to deliver 192 video streams high def to a video wall, which is a cloud demo experiment we're doing at the moment, just to show you what the file system can actually deliver in sheer bandwidth. That might be interesting to some of you. And with that, I say thank you very much for the attention.